So we're the team Djangos on Chain, and we are gonna present the weather use case. So our team is conformed by Elias Corazani, me, Josue, Ashmita, Goma, and Mesba. And yeah, I'm gonna talk about the problem that we try to solve, the solution we proposed, the tools we used, and the architecture of our project. So the problem. We wanted to design a transaction application keeping the security and the information in a decentralized way and avoiding use centralized parties and cloud technology. So for this solution, we proposed blockchain, because blockchain, as the previous team explained, is a decentralized technology as well secure. So we thought it was the best approach for this type of problem. So why blockchain? So as I explained, it's decentralized. One way to explain this is the way Wikipedia works. So Wikipedia has more than 130,000 editors, all working at the same time. So how can they ensure that the information is reliable, is not manipulated, and is secure? So all of them can edit, but it has to be peer reviewed, and the registered users can check and decide whether it's accepted or not. So this is pretty much how blockchain works. That's a decentralized mechanism. Then it's secure. It has cryptography, and it has extra layers of security. So we know it's secure, and as well as immutable. Because, as well, let's imagine we have a book. We have the summary of a page, and in the next page we'll have the summary of the previous page, and so on. So if we want to modify a page, we will have to modify the rest of them. So as well, this is how blockchain technology works. Every time we add a new node, it has information of the previous one in a way that we cannot modify it. So it's against corruption, as I mentioned with the Wikipedia example, and it's distributed. So it has several nodes, and in that way, it's decentralized and distributed as well. So the blockchain's elements that mentioned, it's peer-to-peer, so it has to be revised by all of the, well, not all of the users, but several users, and all of the nodes have equal power. So there isn't one node that will have more power than the others, keeping like equal for all of them. It has cryptography, as I mentioned, so it's secure. It has a consensus, and it's reward and punishment. That means that if the users keep adding nodes, they can be rewarded with tokens, but if they try to hack it or to change it, they will be punished. So how the smart contract works? Let's say we have a group of investors, and then we have a contract. So if the contract is successful, then the payment will be sent to the project team. And if they send the money and the contract fails, then it will be refunded. So in that way, we know the contract is like the main authority here. The contract will decide whether the transaction will be done or not. And yeah, that's one of the advantages of blockchain, because there is not like a central party deciding whether to do it or not, but it's the contract itself that will authorize or refuses the transaction. So what are the top cases of blockchain for 5G? So in this use case, we're using this, we're collecting data from the temperature and humidity in this room, but it can be used for several different things. For example, in banking, for all the transactions, it's a good example that can be used. For insurance as well, all this personal data can be secure in a decentralized way. As well for healthcare, digital identity, education. For example, we know all of our data is collected by big companies, and we know they own them, so in any time they can be hacked. It has already happened with many of the big companies. So if we ensure that our data is decentralized, it's safe for the user. We'll be safe that our data is not in hands of only one centralized party. As well for governance, in the music industry as well, in the gaming is now one of the new trends, and it's like a big opportunity of business there. And in the supply and management as well, it's really well used. So some examples of how IoT and blockchain interact. So there is no central authority, and we know that IoT devices are increasing, and now we have like big amounts of data. So the more data we add, the more nodes we create, and it's getting more secure. As well, we have, as I mentioned, we can use it for supply chain, the IoT network management, to authenticate users. That's really important because it's personal data that we can keep secure. For smart contracts, we can use this paradigm to create, like, for example, in a, let's say we have a transportation company, so the package should be delivered from one point A to one point B, and if the contract is fulfilled, we can process with the payment. If the contract is not fulfilled, then it won't process and it will be refunded. Then, what's going on? Yeah, so our solution for this problem was to use, we create a blockchain based on Ethereum. There is a well secure and robust technology for blockchain. So for example, we have different solutions for blockchain. For example, there is the big chain DB that is consistent and is scalable, but it's not fully decentralized. So we went for Ethereum that is as well consistent and fully decentralized. So in that way, we're ensuring that our data is completely decentralized and not partially decentralized. In the architecture for this solution, first we have the IoT device that is collecting the humidity and temperature in this room. Then we get it from a broker. This broker will post it into the blockchain network, and then from a front-end device that is the end user, we can access that data. So the tools we use for this, we have an Arduino that is sensing the temperature in the room. We use JavaScript and Web3 for the broker. Web3 is an API that enables connection with blockchain. And we create a local Ethereum blockchain, so this is our own network blockchain. And then we create a front-end website that we can access from any device, and we can check the temperature and all the details of the transactions. So yeah, and another example of how important is this technology, with this metaverse that is aiming to create a new world in a virtual way, they're aiming to do it in a centralized way. But if we manage to process all this data in a decentralized way, it will be an exact replication of the real world. So yeah, that was it. And yeah, you have any questions? And as well, I can show the demo if you want.
Any questions?
Yeah?
Okay, I mean, the question is also from the previous thing also. Like, how reliable is your network connectivity? I don't know, which server are you guys using, or are you like...
Well, now it's deployed. Okay, I'm going to go back to the... So, this architecture allows you to... You can have several sensors in, let's say, different cities, different rooms, whatever. You will have a broker that will be publishing to the network. The network is now running locally at Elias PC. So we create our own network. It's not like a public cloud that runs like another blockchain. So far, the way to hack a blockchain is like the 51% rule. So if you have the most of the network, then you can own it. But the more data you get and the more users you add, is like it starts splitting into more users, so it's harder to do that. So for example, technologies like now blockchain or Bitcoin is kind of impossible to hack it because it's not possible to have more of the half of the network for yourself.
Okay, but like when your system is like different users are using like this specific server, just like the case of the recent outage in AWS and like caused a crash in the cryptocurrency. So are you guys planning to manage something like that in case maybe your users are using the same cloud services and like they have outage, and how do you manage?
Yeah, so I think that's the problem with a centralized party, that since they have everything, like you could see a bad configuration can blow the entire system, and somehow if you are like decentralizing and as well, yeah, not collecting everything into the same single thing is like more secure, and it's more the consistency and the idea that it's not like a private company or some single thing that will governate all the information and all the like permissions and everything, but the network and the contract. Yeah.
So, you went from the Ethereum technology here,
Yes.
which is fully decentralized and consistent. But what about scalability? Because you are not pushing very sensitive data. I mean, if it's any transactional data like bank transaction or something related to money, then you can put those information in the block. But we know that the block size are not like a big database. It's very
Yes.
small. And if you put all the sensor data there, then it can't. I mean, you can't scale it that much. So
Yeah.
what kind of information you're going to get? Because for the previously they're using MongoDB, so that's not blockchain. So they can put data, the sensor data there, and they can scale it. But in your case, if you want to put all this sensor data, which will be a lot, considering it produce data in every second.
Yeah.
So
Well,
how do you scale it?
we-
Do you use another database or something?
we kind of focus it in this use case, so we thought like for this specific case that was the best possible implementation. But yeah, I don't know, probably as this diagram shows, if we wanted to scale, probably we should go either for IPFS or big chain database. But yeah, like for this specific problem that we are aiming to solve, we decided that Ethereum would be the best solution because it's fully decentralized and consistent.
The main question was to answer the decentralized, to remove the centralized, and it was not about big data. So if that's why we chose this, because the main problem was decentralizing, not about the big data. But I think it can be further used maybe with combination with something like Hadoop later or something like a big data manager. It
I'm
can
not
be
talking about big data. The thing is, the block size are very small. It's like 2 MB to 6 MB. So usually when you do something like that, they follow a bit more permission way. So in that case, what they do, they only put the sensitive information like credentials or some sensors, like the users who will access that, those information in blockchain. And they use another database like StateDB or like MongoDB to put this sort of information. Like they are using both kind of database. One for storing information, one for storing credentials.
yeah, maybe for scalability then we can further change it. This is like just for decentralization.
Yeah, we really focused on decentralization and not that part because the problem statement was something like we have to consider this is the highest priority. And for that we can use IPFS, which is like just a simple modification.
Okay, we are running late. Can you do a quick demo
Yeah,
for
sure.
us?
I was planning to ask a question. Is it okay if I ask?
You can ask your question while he's preparing the demo.
Okay. Yeah, so the question is about the GDPR and users' credentials and the data. Do you have any solution regarding your implementation protecting the user data?
Well, in
I think lots of people are doing that already. In the blockchain, it's highly secure. It's not penetrable. So we did not consider that. We are not doing that, but yeah, that's possible. I think.
So yeah, this is our demo. Actually, it can be accessed through that link, arctic.herofine.ovh. So it can be accessed also from your mobile devices if you want. Yeah, so this is the current temperature in this room. It sends every 10 seconds. We also calculate the real field there. Then, okay, here in the bottom we have this is the timestamp. So we can see we have been sensing. So since like 11.14, we can see, well, there is not a big change. The sensor is upstairs, and as well for humidity, it has been pretty much consistent. And then in the next tab, we have the information about transactions. So there we can know like the blockchain information, the block hash, the block number, and the transaction. So the first one, since it was like the very first one, it couldn't send to anyone. But then in the second one, we can see that it was from the first one to the second, and then it's how each node is like keep adding to the next one. Then we have all the historic data. So yeah, this will be the user endpoint that the user can access and check the information that is being sent.
Okay. Thank you very much.
Pluggat i.